In my previous tutorial, I showed you how to manage fire. Before adding more effects, I want to focus on the picking mechanics. For the assets and the repository used in this tutorial, please check the description below. Before, we had the torch attached to the player's hand. Now, we want to be able to pick up different objects. We start by editing mannequin. We open player's scene and open its mannequin scene. In skeleton, we add a skeleton eye key. In the inspector, we set upper arm R as a root bone. Inverse kinematics will propagate up to this bone. And we set hand R as tip bone, the bone that will control the inverse kinematics. We enable use magnet and set magnet X value to minus 0.435. This will help with elbow orientation. Next, we need to add a target. We will need to add a position 3D, but since this project will grow in the future, let's add some more nodes. We add an area with its collision shape. This will be used to detect pickable objects, but will also be the container for end target. Area will never alter its position, rotation and scale, and this will be very useful when we will throw objects. We use a capsule shape and position it so that it can touch the ground, but also all the area surrounding the right end. Then we add a position 3D and another one as child of the first position. This one will be our eye key target. When we will set the target, we understand why we need two positions. As soon as we activate eye key, the hand will be twisted in a very unnatural way. Inner position will be rotated to restore a natural position when eye key is active, while outer position will be used to actually control movements. Next, we add bone attachment and set bone name to hand R. We add a child position 3D node that we will use as an offset for rotation and location of the picked object. The best approach is to enable use local space and rotate and translate the position node so that the gizmo arrows are pointing the right up and front directions. In previous tutorial, I used the eye key target directly to attach the picked object at the end position. But that's not optimal, because bone attachment will always stay in the same position of the end, making it optimal for the object to follow. For now, we don't save the area as a separate scene, but we can add a new script. I add a class name, pickEnd, and a few variables. Pickable object is a reference to an object that can be picked. We could simply check if it's null to understand if the player is holding an object, but since we need some interaction with objects when they are inside our picking area, we add a boolean called picking that keeps track if the player is holding an object. Then we have references to the end inverse kinematic and to the right end position, the child of bone attachment. In ready function, we yield for the owner to be ready, so we are sure all children are ready. We get a reference to skeleton and use it to initialize end eye key and the right hand position. We connect body entered and body exited signals. In body entered, we first check if the player is holding an object and return if we already have one. Then we check if the body is in group pickable. If so, we set pickable object value to body. Body exited is similar. If the body is pickable and player has no object in hand, we set pickable object to null. We need to check we are not picking because we don't want to lose any reference to a picked object. So any other pickable exiting of the area will not interfere with our actions. Next, we add unhandled input function. We check if button interact is pressed, while a pickable object is reachable. If so, we set picking to true. call a pick method on the object passing right-hand position, and finally start hand eye key that will override skin animations. If you start from the previous tutorial code, you may have a line of code in mannequin script that starts the inverse kinematics. Let's remove that line. Now let's open hand torch. We saw it before. It is a rigid body with a mesh, a collision shape, and our burnable node. Now we will review the script used in previous tutorial. We add a class name, pickable. In previous version, we had an export var to set a node path to follow. We removed that as we will set the target in-game. In ready, we make sure the object is added to pickable group. In process function, we check the presence of a target and then we copy its position, global transform origin, but also its transform. This will be useful especially if we create complex eye key animations that involve a rotation of the hand. Finally, we add getPickedBy function. The argument is a generic spatial node, but it has all the information about 3D transform and position we need, making the function a little bit more flexible. We set the picker as the target and set the mode of object to kinematic. This will allow us to manipulate the object as if it was a character. We can run the code and see that when we press Interact button near the torch, it gets picked. It is still not perfect. We need some information to understand when we can pick an object. In future, we will add a proper HUD, but for now, we will highlight objects using a shader. We go back to HandTorch 3D view and select its mesh instance. In the inspector, click its mesh and as you can see, it has two surfaces, each with its own material, a light brown and a darker one. Let's click one of them, go down to Material tab and add a new shader material in Next Pass. Here we will add an outline shader. It is taken from GDQuest Shader Materials repository. The only thing we need to know for now are uniform variables that have the same purpose of export vars in GDScript. We have thickness and outline color, and we add a float active to act as a trigger for visibility, but we could have the same result using thickness. We will save the next pass material in a separate file, so we can use it and set this material also in the other surface. Uniforms and separate file will be useful because we will need to make the materials unique later, so adding a controllable shader will allow for easier customization without rewriting slightly different shaders, while the file will simply ease adding a next pass material. Let's go back to the mesh instance node and add a script. We assign a class name, highlightable. We add a constant to store the actual name used in the shader. Be careful because it's case sensitive. It's not necessary, but I find it useful to reduce errors when writing the name multiple times. We add an export var highlight that will activate the outline shader. We set false as default and define a setter. We can add export vars for other uniforms for easier editing. We also have a var to store the number of surfaces in current mesh instance. In ready, we add to group highlightable. We get the number of surfaces in the mesh, and we call a utility function that will set a value for a given shader parameter, or uniform. This utility function takes the name of the uniform we want to set and the desired value. This is for float, but we can write specialized version of this function. Then we iterate through all surfaces, get their materials, and set parameters for their next passes. Please note that the shader parameter is accessed by combining the uniform name with the string selector shader param. Finally, we write setHighlight. This function simply evaluates the new value of the var, converts the bool to a float, 0 or 1, and then it sets the parameter using our utility function. Go back to our pickable script. We add a couple of vars. Mesh is of type highlightable and set to null. Then we have a bool that we will use to activate the highlight. Its setter will obviously update the value, and then if the mesh is not null, it will set the value to highlightable object. The last thing we need to do is initialize the mesh var. In ready, we add a for loop that will iterate through all the pickable object children. If a child is in group highlightable, it will set that as the object mesh. We do this because when we use an imported 3D object, we are prompted to use an inherited scene that we can edit, but not necessarily the new object mesh instance can be edited. In this way, we can recognize an highlightable object just by assigning a script instead of editing the name. Before testing, we need to turn on highlightable from our pick hand when an object is reachable and turn it off when it's picked or out of reach. Let's make a new pickable. I have a wooden sword. We open the scene, create a new inherited one. We change the root to rigid body and drop pickable script. We add a collision for the pickable. Please remember to set all the right layers and mask collisions. Since it's a wooden sword, we can add a burnable scene to make it burnable and edit its collision. Also, drop highlightable script on mesh instance. It already works, we just need to add a shader material. Since my objects share all the same materials, this should not be a problem, but we need to make sure all materials are made unique to avoid all pickable objects light up at once. We make unique all base materials, all shader materials, and also the shader itself. Last but not least, we need to change the walls and floor bodies. Until now, I used CSG geometries with collision enabled, but they do not work well with small objects, and sometimes the sword passes through the floor. I disable use collision option and simply add a static body with multiple collision boxes. Please note that we can duplicate and position the walls, but we need to add a new collision shape for the floor because it needs different proportions from the walls. Thank you for watching. I hope you enjoyed this tutorial. Next time we will throw objects.